It's important to know whether or not digital filters are stable. It's normally a requirement that the filter be stable. We're going to check in the case of 3 different IIR filters the conditions for so-called BIBO stability. Here we have 3 systems. The first one has its single pole inside the unit circle. The second one has its pole on the unit circle. The third one has the pole lying outside the unit circle in the Z-plane. We're going to test this with 2 bounded input signals. We're going to have an impulse, which certainly is bounded, as is a step. If any of these systems show unbounded output, then they will be declared to be an unstable system. Let's run it. We only run for 30 samples or so. You notice that this yellow trace, which is associated with the first system, decays down and is in fact nicely bounded. Likewise, for the second system, this cyan color is holding flat like a step here, and it's bounded. The third one, however, with the pole outside the unit circle, has its output screaming off towards infinity. We can immediately brand this as an unstable system without any further ado. We still don't know for sure because we haven't tested exhaustively the conditions on the other 2 filters. So let's switch to a different input and run a step and see what happens. This time, as we might have expected, the orange looking curve associated with the third system has gone out of sight. This is on its way towards infinity. This doesn't surprise us because this, we've already said, is an unstable system. What's new really is this cyan curve climbing off to infinity itself. This wasn't the case before, so we can now straight away say that system number 2 is also BIBO unstable. The first system is climbing up here and saturating, so we're still unable to say that this is an unstable system when the pole is inside the unit circle. If we were to exhaustively test every known possible signal, then it for sure would turn out that we would always fail to be able to exhibit instability. Put it the other way, the fact that we have poles lying inside, strictly inside the unit circle, and this one does, is an example of a guaranteed stable system.